All right, so thank you all for coming to my talk, Introduction to Software Logistics. So this is probably a term many people have not heard of. I go around talking about software logistics, or what many of our customers talk about called delivery gymnastics. It's usually one or the other. I'm a huge one for analogies. So you're going to see a lot of pictures, a lot of correlation, and being able to tie that back to technology. And I've been on the working group for the Common Cloud Controls and talking about securing the software supply chain. And all of these things are going to relate back to if you've ever done anything in the transportation industry, a lot of terms, a lot of these things actually overlap. And I used to work for the railroads. So there's a lot of things that I've seen from a supply chain perspective with railroads, multimodal, shipping manifests, a lot of those things that there's a lot of correlation to what we do in the software development process. So first thing is, I loved Kelsey's talk this morning, if you were there, and talking about the young developer who's starting a new project, who gets hired in, and this is sort of your first view. I'm gonna go out, I'm gonna grab the apples, and I'm gonna take all this raw fruit, and what happens is I'm gonna have that amazing apple pie at the end of the day, and I'm gonna be able to go around and talk to everybody about that pie. But unfortunately, what ends up happening is our software and all of the changes that we've made end up sitting somewhere for a long time, and it never makes it out into the real world. And so unfortunately, the apples sit in the back room somewhere and just rot away. I have a really good friend of mine who was at Snowbird. He was part of the Agile Manifesto. His name was John Kern. And one of the things that he would talk about is change in software is sort of like perishable fruit. The longer it sits and it goes stale, the harder it is when we go to deliver it, because there's so many other things that surround it. So a lot of times those things just get abandoned. Now, the next slide is a slide, and it's amazing to me. I've used this slide for a little over 10 years, and I've iterated on a little bit, but it's pretty much the exact same slide that I've used for 10 years. And when we think about software development lifecycle, I've realized as an engineer, as a developer, I've had the opportunity to be an executive on both the development side as well as on the operations side. And when you actually think about those things on the development side, it really is somewhat of a factory type mentality. And it's really not a life cycle. We don't take an issue if we're in Jira, or if we're in GitLab, or if we're in GitHub. A lot of things move from left to right. They really don't go in circles. I take a task, I go work on the task, I close the task. I don't go back and say, oh, it went into production, oh, let me go open it up when I have a change. We just go create a new ticket, and we make whatever modifications we want inside of it. Now, back in the late 90s, there was a gentleman, I cannot claim to own the term software factory. There was a guy named Jack Greenfield that I worked with. He was at Rational Software. He was the first one to coin the term software factories. I hear this a lot in Europe when I go talk to customers. A lot of them come from a manufacturing background, so factories seem to be things that really hit home with them. But the thing that I like to think that I've termed is this thing called software logistics. And software logistics is everything after the package. Now, how many people here have heard the term continuous deployment? Right? How about continuous delivery? Right? How about progressive delivery? Okay, a little less progressive. How about release orchestration? Okay, now I know who the old people are in the room, okay? So, when we think about these two things, my software factory and my software logistics, those two things together make up my software supply chain. Now, As we think about the factory side, I was at the DPE conference last week with Gradle, and I saw so many amazing companies talking about developer productivity. And developer productivity is on top of a lot of people's minds when it comes around generative AI. And the question that I posed to everybody who was at that conference is, can I actually do developer productivity with faster feedback loops, with better security, with automation for delivery, if I'm not doing software logistics properly? And if I'm going down the software logistics side, that is all around operational efficiency. We are seeing a huge rise right now at GitLab around people who have the title platform engineer. And those platform engineers are being responsible for building golden paths, for automating the build cycles, for being able to optimize build cycles. And some of them, as they're building their pipelines out and they're working through this process, they're realizing that there's a lot of things that are wrong with the way that we think about delivery today. And those things are, there's no real way for me to test delivery. There's no way for me to simulate the delivery. And when you think about software logistics and logistics in general, when I work for the railroads, we could go in and use our business process modeling tools that we had available to us, and we could see every rail car that that particular package would run in before it would get into its end state. We would even be able to simulate when it would have to go via ocean and when it would go on a shipping, on a boat, or when it would go via truck. And you could understand when it would need to be picked up and how long it might sit at a port. So those kinds of things we can't do today in software delivery. A lot of the things that we do is we iterate on building pipelines as a goal of being able to try, because that's the only tool we have available to us to be able to do automation in this arena. So if we go back and we just think about what a factory looks like, so this is about me taking my raw goods and getting them into a package format. And yes, I have this up here specifically for a reason, because I love Oreos. Okay, any talk that I give, there are a lot of Oreos in my presentations. Now, if you think about what are all of the steps that I go from the recipe for making an Oreo all the way through to the packaging, it's finite. They don't iterate on that. That factory floor is set up and designed specifically for making Oreo cookies and packaging Oreo cookies. So on that conveyor belt, we do things that we would normally do in the software development lifecycle. We have quality assurance. We get rid of things that are bad. We make sure that the bad things don't end up in our packages. We make sure that every package has a unique ID or an attestation. So somewhere down the road, if something was to happen, I know which package might need to be recalled. Those kinds of things that we do in the software lifecycle, because it is finite from beginning to end, this is where pipelines really work. So when I go out and talk about CI, continuous integration, CI uses something called DAG, directed acyclical graphs. And a lot of people don't realize that directed acyclical graphs are actually a mathematical model. It's not a YAML file. It's not some groovy code. It is a mathematical model that makes something called Turing complete, which means I know that when I get to my end state, based on what the change was at the beginning, I will always be able to ensure that that end state has been met. But it is a one-to-one change set to end state. Now, in any one of the tools that you use, whether it be GitLab CI, GitHub Actions, Jenkins, one of the things that we run into is when we think about the software development side, we're in Git and we're using branches. So I have a main branch, a release branch, a development branch. I've got all my feature branches, my bug branches, maybe a security branch, who knows, whatever you want to name them. But what we do is we only have one pipeline that we have for that entire project. And so what we have to do is we have to do all kinds of magic to be able to do things, to be able to get just to a package. So I might need to say, oh, if branch equals feature branch, then I only want to run these jobs. Or I want to make sure that in a feature branch that I deployed a dev test and only run this set of tests. But at the end of the day, I only have one pipeline. And what happens when we do a bunch of these if-then type of statements inside of CI is it makes it where I can't reuse it. They end up becoming snowflakes, so every project gets its own snowflake pipeline. The only things that I can really share are the jobs that are in the stages themselves. And when we start to talk about being able to require dependency analysis between them, so which job depends on another job, it creates a whole other set of nightmares. Now this is just to be able to get to the package. Now when we start talking about the delivery side, it's even worse. Because a lot of times, a lot of the tools out there that talk about continuous delivery, if you go out and read their documentation, they really have one target, and that's Kubernetes. Let me show you how I can get this container package that you've built and how I can get that into this Kubernetes cluster. How many people have had to deploy to multiple Kubernetes clusters for one release, right? So you have to go to multiple clusters. How many of you have had to be able to support regional deployments of the same artifact with different governing strategies, whether it goes to the EU, whether it goes to APJ, or it goes into the US, right? Those things are hard. Now, that's just one type of deployment. Now we think about what happens if I've got to update my APIs that attach to the Java application running in BE WebLogic that talks to the mainframe on the back end using JCL or using some other technology. I mean, there's just so many different options that you have out there. When we try to do that, that totally breaks down in a CI process. Because remember, it's supposed to be Turing complete. I'm supposed to have one change state to one end state. If I have all these combinations, permutations on the back end, I no longer have one end final state. Deployed does not make it an end state. Because now what do I do once it's been deployed? I've got to observe it. I've got to go in, I've got to monitor it, I've got performance analytics that are associated with it, all these other things. So it's never really done. It's an organic thing. It has its own state that mutates over time. So when we go ahead and map that to an actual release cycle, now if I've got one project as one pipeline, well, if I've got an application, how many people here deployed microservices, right? So microservices, oh, that's easy in Kubernetes. I just apply a Helm chart. Those people that have tried to version control Helm charts with multiple different manifests across multiple different versions, it's not easy. Well, when we think about all these different projects that make up an application, I have multiple different packages. So the way that I solve that problem is I create a release. And that release will end up tying all of the dependencies together. So when you think about this and you do things like semantic versioning, so my application itself is on version 1.18. But then every project underneath it has its own set of versions. So I've got 2.3 of this, I've got 3.19 of that, I've got a Z release and another one. And then you have to build a release manifest to be able to say, all these things are all mapped together and here's where they need to go. Again, very complicated to be able to do, because if you start to think about this pipeline and you start to think about all the stages and all of the jobs that would be required to be able to map all of those things back and forth, you're going to have a pipeline to end all pipelines. And again, most of the executives I talk to are like, we're building golden paths. I'm like, no, you're not. You don't have golden paths. You have golden components, and you're asking them to build paths from the components, but very rarely do we ever see golden paths from beginning to end. So I asked the question. Inside of GitLab, we do these sessions every month, and we have what are called Think Big sessions. And one of our product managers, Victor Nagy, he went out and interviewed 100 customers. And I didn't even know that there was an alternative to DAG. I've been using DAG for so long. I'm a longtime user of Hudson, which is now Jenkins, and so many other tools that I didn't know there was an alternative for this. And he said in our Think Big meeting, he said, you know what? There's an alternative to this. And so now I was very intrigued. I love it when we innovate, we think big. So what if we can think about this from a perspective of, I now have all of my Oreos that are all packaged together in all these boxes, and all these boxes are then packaged together. And then as I go ahead and I move them in between different containers, I now know exactly which container on which ship at this specific point in time has my single Oreo. How many of you can do that in your production environment today? Can say, this issue that was in Jenkins is currently sitting in this specific package in this particular environment, whether it be production, dev test, staging. How many of you can actually have that visibility from end to end with all of those different components? That's hard. It's not easy. Most likely it's because inside your organization, you have many people who have touched that along the way. Sometimes there's even manual processes that go in, and there was a handoff that you were like, rubber stamped it. Yeah, you know what? It's Friday afternoon at 3. Yeah, go. We'll deal with it on Monday. Doesn't matter. So then when we think about being able to not only know when it's in the container, but then I can tell you that that Oreo made it to my house, that it was signed and delivered, and it's now sitting in my cabinet. Or what about if you're the grocery store provider and you wanted to know that it's actually on the shelf? And what shelf is it on, and how long has it been on that shelf? Going back to the Apple analogy, I want to make sure this release is getting out there as soon as possible. So being able to have visibility that it made it to the shelf and it's ready for somebody to buy is very critical. So let's think about this problem again. So now if I think about progressive delivery, so progressive delivery is the concept of me being able to move changes throughout environments, whether that be push or pull, and that's going to be important in a minute. And we think about all of the different packages across a single release that map to now an environment. And that environment is made up of many different components called resources, because these resources, some of them are static, my BEA WebLogic server. Some of them are ephemeral, my container that's sitting in Kubernetes. All of these different components that we have, some of them I need for one environment, and I don't necessarily need it for the next environment. Like, who here would love to go ahead and spin up a new mainframe for their dev test environment, right? We probably have 1 or 2 for the entire company, and we've got LPARs to be able to break up so we know which one goes to what. Well, as we start to think about this progressive delivery concept, you can see how we now have not a one-to-one mapping. I now have a one-to-many mapping. So now DAG is out the window. So if I can't use DAG for this, what would be an alternative? And when Victor Nagy brought this up, they're called Petri nets. I've got to give him credit because I knew nothing about a Petri net. My wife hates Victor Nagy now because I went over the course of about a week going down a rabbit hole of what are Petri nets and reading all of this research documentation. I'm sitting there going, oh, this must be something new. This is like really innovative. Yeah, this was founded in Petri nets called 1962 was the first research paper. And Petri nets have been around so long that one of the most famous Petri nets are, again, another mathematical model that we can use. And instead of thinking about it as a one-to-one, it allows us to be able to build a concurrency model around delivery, but it also gives me a way to be able to model it so I don't actually physically have to run it to be able to see the end state. I can see it incrementally change because the state is changing over time. So there is one famous Petri net that everybody here has used throughout your lifetime. Oh, hold on. I'm gonna go here and then come back. So if we think about a stoplight, so a stoplight has 3 states, right? So green, yellow, and red. And when that light is red, we have a car that knows to stop. It has a stopped state. When that light turns green, it goes into a green state, and it will move from place A to place B. It could be another light, it could be your end destination, it could be an on-ramp to a highway, whatever it could be, I'm moving from place A to place B. So, let's see. So this is what a Petri net ultimately is. It is one big state machine, and it's made up of many places. And between those places, we have tokens, the car. We have arcs, which take me from place to place. And we have transitions that use the state to tell me when it's okay for me to go into the next place. So now if we think about a release, and a release is made up of many packages, that release I can move into an environment, and when it moves into an environment as a place, all of the resources inside of there have their own states. So I could have provisioned. Okay, great, so now I've provisioned it with Terraform. Oh, but wait a second. Somebody opened up a ticket in ServiceNow and they logged into the Cloud Console and they modified some of the parameters. Oh, so it's in a drift state. Okay, well now it's in a drift state because it was in a drift state. Oh wait, somebody else opened up another ticket in ServiceNow and they modified the SE Linux runtime for the IP tables to be able to go ahead and route so that way I could get the data from the security group to somewhere else. Okay, so now it is in a drift state in an unconfigured managed state. How would you do that in a CI pipeline? How would you know what the current state of that change is in a CI pipeline? And how would you react to that change to know that you need to go back to a good known working state before I could ever even deploy that particular package via whatever mechanism you wanted into that particular environment? And then how do I know that anybody here has ever worked in a production environment where you have, let's say, an outage or you take some sort of security incident, whatever? We update production as a hotfix, but we do not necessarily roll that through all the other environments. So when now I'm testing in my pre-production or my dev environment is not my production environment. My version of Kubernetes is not the same because I patched Kubernetes in production for a hotfix that wasn't patched in dev test. Well, what if that actually has an impact? Again, I can't see that in DAG. I'm always pushing everything forward. But without knowing the current state of change across everything underneath, I can't deliver it effectively. So one of the things that we are playing around at GitLab with right now is maybe there's a different way. Maybe we shouldn't be building pipelines for delivery. Maybe it shouldn't be a workflow that you do where you're just going ahead and asking it to go run a bunch of commands. Maybe it is a series of state machines. So I've got a state machine inside of a state machine. And as you think about these changes, now let's say I want to provision an EKS cluster. How many people have provisioned an EKS cluster with the Terraform module, just the base Terraform module? Okay, a few people, right? It's an all or nothing thing. So I've got to provision everything from beginning to end. There's no way for me to test when I create the VPC. There's no way for me to test the VPC was created. I have to assume from Terraform that it is declarative, knowing that it's going to be provisioned, and then I can use that value in the next phase of the deployment. But there's no way for me to interject anything in between there to be able to validate that the VPC, yes, it may have been created, but is it using the right IAM profile? Have I configured the right security groups? Is it sitting in the right VPC? Is it sitting in the right landing zone with the right VPC? We have no way of being able to check those things. So imagine in a world, and this is very important when we talk about the cloud controls environment, is this is EKS. The model that I'm working on right now is being able to generalize this. So we would be able to use this where I could say, instead of asking it to provision an EKS cluster, I could say I want a Kubernetes cluster. And then what I could do is I could have, using the state machine, I could give it metadata and say, in AWS. And then it would automatically know to be able to go to AWS using my AWS credentials to go provision it. But I could also set that metadata to be GKE, or AKS, or on-prem. And every single one of those would use the same policies, the same rules, everything around them to be able to validate all of the precursor items exist based on the environment that I'm actually targeting that particular delivery. Well, how would I do that? And this is something I learned that was very interesting about financial services, is something about infrastructure and BDD tests. So when we're provisioning infrastructure, they want to use Gherkin because this is what they hand to a lot of their auditors. And they're like, yes, these are all of the checks that we do to be able to validate the infrastructure that's being configured. So I can now run this. Most of the time when we do CI, we have to validate after the Terraform script has been run for me to be able to know that it was provisioned properly. And usually it's done via an eyesight check, not through any sort of automation. We go in and say, yep, I could hit the EKS endpoint, I'm good. We don't actually know that all of the different steps, that they were all done properly. So what I can do here is with Petri nets, I can simulate a deployment. I don't actually have to build an EKS cluster. I can simulate it with all of the rules that I need using natural language inside of a Gherkin test, and I can know based on the DSL that yes, this will perform exactly the way that I want. So I'm seeing a lot of posts on LinkedIn, on Medium, on other things. There's a lot of people that are starting to realize this themselves, that CI and CD are two completely different things, and we should be using different technologies for being able to solve that. So I was sitting underneath a tree at a jazz fest, and I was in Savannah. I live in South Carolina. I was in Savannah, and I was looking up and I saw this tree with this amazing moss coming out of it. And I was like, oh my gosh, that is what CD is. It's this mess of all of these things going in every different direction and trying to understand what that looks like. Where CI, anybody here who has ever done CI or inherited a pipeline, it's the cactus. It is prickly. Nobody wants to touch it. So when you think about these two things, I'm hoping that you get a visualization as you go back and you leave, that when you think about what software factories and software logistics look like, know that software logistics is about trying to make sense of this side, where creating the package is thinking about the cactus. And with that, I want to thank you. Any questions? Yes?
When you're using Petri nets or modeling things using Petri nets, do you explicitly allow loops back again? Because DAGs obviously preclude that.
Yes. So one of the unique things is there are multiple versions of Petri nets. And the one that I have seen that is most closely related to what we would want to do from a CD perspective is what's called a logic-based workflow Petri net. They are used a lot with things like legacy business process modeling tools. If you go in and look at the heart of what they were intended to be used for, that would be a logic-based workflow Petri net. Because anybody here has ever done business process modeling in the past, we could go ahead and let's say I've got an order and somebody places an order online. You could walk it through the entire system before ever deploying any of the code to be able to make sure that, let's say, because I'm a gold customer, I automatically get my 20% discount automatically applied at checkout. Well, you don't want that to happen, that after somebody places the order that they never got applied, and then you get an unhappy customer afterwards calling up and saying, hey, I want to let you know I never got my 20% discount. Well, how do I go back and backtrack that? How do I go back and replay that activity? This is the same thing that we want to do in delivery. Everybody that I've talked to around wanting to be able to do delivery wants to be able to do the same thing they do in CI, build individual components, assemble them together, and then do exactly what you describe. I want to be able to play that out, and I want to be able to place logic, and I also want to be able to have loops. Like, what if I want to go ahead and I want to set up 3 Kubernetes clusters? I don't want to rerun one Terraform script 3 times. I want to be able to just have a loop that says do this 3 times, and it goes off and does it automatically for me. And that is what the Petri nets would allow us to be able to do. The other item that I didn't mention is when we think about it, so many things in CI, we always think about just pushing things forward. Inside of Petri nets, if I build it in the right way, I can also build compensating transactions. So if I need to do a rollback, I can roll back all states of every resource all at once. I can make it transactional. Now that is something that I know is very hard to do today. If I've got an update to a database and I applied a DDL that updated a column that was going from a small int to a big int, okay, well, what would you do to be able to roll that back? Most people be like, just leave the database alone. Oh, but now all of a sudden 8 of my queries don't run anymore because I specifically said what data type I was looking for. Those are the kinds of things that make our deployments so fragile. So, but great question. So right now it's in what we call a think big state. So what we're doing is we're going out there and using this as a thought leadership exercise to be able to say, hey, is this something that from a delivery perspective, is this a challenge you're trying to solve? If it is, we would love to talk to you. Our product teams would love to be able to learn more. We have a lot of the components, so we've got environments, we've got releases. We know that we've got to do some things around those to be able to make them more state aware rather than being CI or DAG aware. So to be able to do those things, we're going to start building some of that plumbing underneath the hood. But then a lot of the things to be able to support DAG on the back, or support Petri nets on the back end, that would be something new. We'd still use existing runner fleets under the hood to be able to provide the execution. But instead of using a GitLab CI file to be able to describe it, there would be a different way that we would use Petri nets to be able to do that on the other side. But if it's something we'd love to be able to have a conversation about. You are thinking exactly the way that we're thinking about it. I've got tags in my CI. We could reapply those tags. You've got merge requests that have labels. I could use those labels. I could use all of that metadata to be able to give me an enhanced state. Like everything that I've read, they talk about having single states. We're thinking about where you'd be able to have multiple states and then being able to have rules across all of those states. And we could pull all of that data. So right now, instead of having declarative deployments, you'll be able to have imperative deployments. So as long as the right things have been tagged properly, we would be able to make a lot of assumptions about current and existing state and being able to move those things through the system. Yep. Great. Well, thank you all very much. I appreciate it.